One of our research aspects from the Building Resiliency Task Force report was really focused on passive survivability. How long can you potentially stay within a building, depending on the condition of the facade, depending on how much insulation is in there, the quality of the glazing and the windows, how many days are you able to survive in that building without power? And we can't have backup power solutions necessarily for every project, every building. Hospitals, other critical care facilities focus much more on those aspects because they need to continue running. But when we don't have power to multifamily residential, what do we do? And our thinking about this really is in terms of big R, big resiliency, and also little r resiliency. Big R resiliency being when the storm event happens, when the disaster happens, how do you respond? Little r also being the same technologies, how do those respond on a daily basis? How can a better building envelope not only give you a few more days of passive survivability during a storm event, but also improve annual average energy bills, thermal comfort within the built environment. There can be a lot of win-wins or multi-benefits for both.
So without mechanical heating and cooling, the building envelope is really our only line of protection, so including the windows, walls, and roof. In Urban Green's Baby It's Cold Inside report, they liken the building envelope to an article of clothing, saying that if New York City buildings wore clothing, the typical building would have on a light jacket, not warm enough to wear outside in the winter and not insulated enough to maintain habitable apartment temperatures during an extreme weather event without power. So we ask, what extreme weather event should we design for? And this includes new design and retrofitting. And how puffy should our jackets, or how puffy do our jackets need to be to maintain habitable temperatures during a power outage? So this question of habitability and thresholds is a big kind of initial question. And while ASHRAE thermal comfort is relatively well defined at this point, those extremes of habitability are still being investigated. Post-Sandy, the Resilient Design Institute and the Building Resiliency Task Force identified 50 degrees as a reasonable lower threshold, maybe a conservative lower threshold for habitability, and 90 degrees Fahrenheit as an upper threshold. And it's important to note that these, beyond these temperatures, it's really about extended exposure beyond these temperatures, and observations that extended exposure beyond these temperatures increases the likeliness of thermal disorders such as heat disorder or hypothermia.